Okay, ji. Permutation combination lecture number 5, case number 6. This is repeated letter arrangement. Now let's just say that normally we had A, B. So when we had A, B, these two letters are very different. So that means we can write this thing as B, A as well, placing the second letter first and the first letter afterwards. So for this, what we did was 2 factorial, which was that this has two arrangement in total. Similarly, we had A, B, C. For ABC, what we did was we had 1, 2, and 3 letters. To obviously arrange them, we used what 3 factorial, which was equal to 6 ways of writing A, B, C. But now when we know that we are working on repeated letters, we should know that for suppose if A and A are there. Now you write A in any way, like say that A and A is written, that means second A is written at the first place, first A is written at the second place, but the original value of A and A will remain same. That means even if they look alike, that means their arranging method is 1. So what we do is we write this thing down as 2 factorial and divided by the repetition of the same letter, which means divided by 2 factorial. So that means the answer would be 1. Similarly, if we have what? A, and A. So now we have 3 A's. So for this, what we do is 3 factorial for the moment, but obviously we need to divide it by with 3 factorials to remove the repetition. So that means the answer would be 1. That means in any form, if you write A, that will still remain A, irrespective of the fact that even if you put down the third letter at the first place and the first letter at the third place, still it will be A. Similarly, if I say AAB, or we write down as ABA, or we write down BAA. So in this way, can we just say that with the repetition of 2 A's and a B, what are the other forms? We can write down 2 A's and a B, that means 1, 2, 3. So this should be 1, 2, and obviously this third B is in the middle. Then we can write down 3, and obviously we can write down 1 and 2. Even if we place 2 and 1, if we place second A at the first place and the first A at the second place, and first A at the first place and first A at the second place, still it will have 2 A's and a B. So for that, this what we do is 3 factorial for the movement and 2 factorial divided by 2 factorial to remove the repetition. So this means 3 into 2 into 1, which means 2 into 1. That means the only possible ways of writing down 2 A's and B are 3 ways. That means we can write down AAB, ABA, and BAA. These, to write down 2 A's and B, we only have 3 particular ways of writing this. Okay, Ji. Now what we need to understand is that we have 3 A's and B. If we just say that we have 3 A's and so we have 2 A's and B. Let's say that we just did 2 A's and B. Now we are working on 3 A's and a B. Now to change this, we can always write 3 A's and a B with 2 A's, B and A. We can change it with A, B, 2A. We can change this with B, A and A. Now to write down this thing, we can have only 3 particular options. So what we can just do is we can directly write down 4 factorial and divided by 3 factorial, because 3 A is being repeated 3 times. So if we just open this 4 into 3 into 2 into 1 divided by 3 into 2 into 1, 3 to 1, 3 to 1 is cancelled. So what we are left with is 4 only. So that means your first position, your second position, third position, and fourth position, there are 4 different ways to write down 3 A's and a B together, when obviously 3 A's are being repeated. Similarly, with the same example type of question, if we say we have 2 A's and 2 B's. So what are the ways of writing down 2 A's and a B? So we can write this as two B's and obviously two A's. We can write this thing as B A B A. We can write this thing as A B A B. We can write this thing as A B B A, and we can also write this thing as B A A B. So these are the only ways to write down two A's and two B's together. But obviously, if we write down with the help of factorial, we can write this thing as 4 factorial upon repetition of two A's multiplied by repetition of two B's. So whenever you have two different alphabets being repeated together, we write them separately in the denominator. So that means this 2 factorial can be, the first 2 factorial can be repetition of two A's, the other 2 factorial can be repetition of two B's. So considering the same aspect of the question, we can work it through that this thing will give us 1, 2, 3, 4, 5, 6. This will give us 6 different options of writing down two A's and two B together. Now let's work out with the example number 1. Example number 1. If the word is evermore. Now, in this word, what we can see is, we can see 3 E's and 2 R's. The question can be very simple, that we can write down, find the number of arrangements, find the number of arrangements without any restriction, without any restriction. Now, since we know that this is without any restriction, and knowing the fact that evermore has 3 E's and 2 R's. So how many alphabet does this have? 1, 2, 3, 4, 5, 6, 7, 8. This has 8 factorial for the alphabets. Similarly, but we can see that 3 E's are being repeated. So 3 factorial is divided. Multiply by 2 factorial is divided for 2 R's. So this means 8 factorial in the numerator for the entire arrangement. And then since we need to cancel down the same variable, same names, so we need to make sure that 3 factorial and 2 factorial is being applied. Just as example, this will be 3360. A small example here can relate to my name, that is Adil. This is, we have 2 E's in this. Even if I write down Adil in this form, having second E first and the first E afterwards, the name will not change. The name will still remain same. So we can do 5 factorial upon 2 factorial to find out the number of ways in which Adil can be written. Now, knowing the fact that this example, the word evermore, can also have another type of question such that find number of arrangements which starts and ends with R. Which starts and ends with R. So what we know here is that it should start and ends with R. Now there are two particular ways to solve this. Number one, we can do it with fixed positioning. If we fix the position 1, 2, 3, 4, 5, 6, 7, 8. So what does this mean? This means we need to have R at the first place and R at the last place. Now, if we are just fixing this position, then we should know that the second R, this is your first R and this is your second R. The second R will not come at the first point and the first R will not go in the second R because this is already fixed. Since this is fixed, what will matter to us is the alphabet that will be in the middle. How many alphabets we will have? 1, 2, 3, 4, 5, 6. We will have 6 alphabets in the middle. Knowing that 6 alphabets are there, we will arrange only the 6 alphabets because the first R and the second R are already fixed in their position and it is starting and ending with an R. Since we are using the fixed fixed positioning method, we will only be arranging what 6 factorial, all the alphabets in the between. But knowing the fact in this 6 alphabets, we also have 3 E's, which are already moving with the 6 factorial as well. So that means to complete this, we should be dividing our 6 factorial divided by what? 3 factorial to get the answer, which will be 120. Now working out, since this is your fixed positioning method, now since we know we are not fixing the position now, let's just work this thing with another example of working. Let's say we have 8 alphabet, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Now we have 8 alphabets writing down, knowing the fact that in the first point, we need to write down R, and in the second even we need to write down R. Now, since I'm not doing fixed positioning, for the first position, I need to write down R. I have 2 different options of R's. Out of that 2, only 1 can come here. So 2C1. And since 2C1 is at the first position, we will have 1C1 in the last position. We will have 1C1 in the last position because the second R is left. Now, how many alphabets do we have in the middle? 1, 2, 3, 4, 5, 6. So that means 6 factorial will be used for this. And since 6 factorial is used, we know that 3 E's are here in the 6 factorial type. So what we do is 2C1 into 6C1 into 1C1 upon 3 factorial for 3 E's. But we will also be using what? 2 factorial for 2 R's, because when we are using 2C1, that 2C1 will mean that any of R can come. We have 2 particular R's. So any R can come at the first position and any R can come in the second position. So considering this, that any R can come in the first position in this particular point, if the first R comes here, then second R will come here. Or at the first position, if second R comes here, then the first R will come here. That means the movement is still there. To finish that movement, what we will apply is 2 factorial in the denominator. In the second part, what we did in the last working, what we did was, in the last working, we made sure that R is fixed. This will not move. Your 1 will stay here, your 2 will stay here. 2 cannot be placed at one side, 1 cannot be placed at the point of 2. That is the reason we use fixed position, and we did not use any 2C1 or 1C1 here. But when we are not fixing the position, we will be using 2C1, because there are 2 possibilities of having 1 R. So 2C1, and obviously when 1 R is here, then we will have 1C1 for the second R. Similarly, we'll be using 6 factorial for the movement of the other alphabets, which will also include what? 3 E's. So 2C1, 6 factorial, 1C1 divided by 3 E's, and this will give me 2 R's. So the answer will still remain same. That will be 120. So the answer will be what? 120 here. Another example, find the number of arrangement that starts and ends with an E. Now, since we will be using both methods, let's just say I'm using the first method, fixed position, 1, 2, 3, 4, 5, 6, 7, 8. Now I know that using the fixed positioning method, I know E is here and E is here. So when E is at the first point and second E is at the second, your third E is in the middle. It really does not matter where it goes. But I know that third E will be moving. So that means 1, 2, 3, 4, 5, 6. We will be using 6 factorial for the movement of the 6 alphabet, including 1 E. That 1 E can be moved anywhere, but the E, those are fixed here. E, those are fixed here, will stay here. It will not move anything. This E can be moved anywhere in this particular blanks. So knowing the fact that we have 3 E's, 2 E's are fixed, so we are using 6 factorial upon, but remember 2 R's are in the middle. Now 2 R's are in the middle. To finish the movement of 2 R's, we will use 2 factorial for the division. So that means your values will be what? 360. Similarly, in this way, if we are not fixing the position, if we are not fixing the position, let's say 1, 2, 3, 4, 5, 6, 7, 8. Now, how many E's do we have? We have 3 E's. So at the first E, what we do is 3C1. And the last we will do 2C1. And obviously, when 3C1 and 2C1 is there, 3C1 means any E can come here. So that means the placement of first E in the first blank, second E in the first blank, third E in the first blank is there. Similarly, 2C1 means the remaining two E's can come here. If the first E is here, first E is here, we can use the second E here. The second E is there, we can use the first E here. The third E is there, we can use the first E here. The third E is there, we can also use the second E here. But with the respect to the other alphabets, what we have is 6 factorial for the movement. But since this is not fixed positioning, we will do 3C1 into 6 factorial into 2C1 upon 3 factorial to eliminate 3 is the same alphabets, that means, and 2 factorial to eliminate the R. So this means that 3C1 is any of one R out of 3. 2C1 in the last blank, any of one E, that is remaining. 6 factorial for the movement of 6 particular alphabets. 3 factorial to finish the movement of the same words, and 2 factorial for the movement of 2 R. So that means this will give me 3 E's, this will give me 2 R. The answer will remain same, and the answer will be what? 360. Okay, G. Another example, the word is selection. And now in the selection, what we can see is the repetition of two E's. So that means two E's are repeating in this. So when two E's are repeating, let's just work out with the example question. Arrange the alphabet without any restriction. So how many alphabets do we have in this? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 alphabets, and obviously two these are being repeated. So we will divide. So the answer is 181,440. Then moving on, if I just say that arrange the alphabets such that both E's are separated. Now, when both E's are separated, so what we do is we have 9 alphabets. So let's just say we write down the remaining alphabets S, L, C, T, I, O, N. So obviously 1, 2, 3, 4, 5, 6, 7. These all the alphabets will be moving. This should be what? 8C1. This should be 8 factorial. And this 8 alphabet, we have how many gaps? We have 8 in, we have total of what? 8 gaps. In the 7 alphabets, we have 8 gaps. 1, 2, 3, 4, 5, 6, 7, 8. So if I just place the first E, this should be 8C1. If I place the second E, this should be 7C1. And upon this should be what? 2 factorial, because of the 2 is being repeated. So the answer of this should be 14120. 141120. So this would give me that 7 factorial is for the movement. 8C1 is for placing the first E in the gap. How many gaps do we have? 1, 2, 3, 4, 5, 6, 7, 8. Since we need to separate, we'll be using the gap method. And since the first E is placed, now we need to place the second E, so that we will have 7 gaps. So this should be 7C1 divided by 2 factorial, because we need to end the repetition. So that means dividing it with what? 2 E's that we will have. Now let's just move to the other example part of this. Let's just say that we need to arrange alphabets such that such that both e's are together. Now, since both e's are together, so what we do is we will have 1, 2, 3, 4, 5, 6, 7, 8, 9. Placing both e's together, this will give me 2 factorial upon 2 factorial. Because of having 2 e's, and obviously we can eliminate the 2 e's as well. And how many alphabets do we have? 1, 2, 3, 4, 5, 6, 7. 7 alphabet, and the eighth one is block. So this should be 8 factorial for the movement of 7 alphabet and the block, and 2 factorial upon 2 factorial for the movement inside the block with the same ease. So obviously this will be cancelled out. That means this will only give me 1. So the answer of 8 factorial is 40320. Considering the same thing, let's just work out this thing again. If I just say that we need to have the 2 e's together, to have 2 e's together, what we need to do is we need to have 2 e's in the block. So if I want to place 2 e's in the block, so what we do is we make sure we write down 2 e's together. Now placing 2 e's together, we'll have the movement as well. When in the block, when 2 e's are together, this will be 2 factorial upon 2 factorial. To finish the repetition of 2 e's, 1, 2, 3, 4, 5, 6, 7. 7 alphabet and 1 block means 8. So 8 factorial for the total movement, and 2 factorial for the movement of 2 e's, and 2 factorial to finish the movement of 2 e's. So the answer should be 40320.